Our next presentation is going to be by Liz MacDonald in place of Michael Hunnicle, who was not able to make it today. The poster is called An Aurorasaurus Citizen Science Database of Strong Thermal Emission Velocity Enhancement, Steve.
Okay, can you guys see my screen?
Yes.
I'm moving around the poster.
Yes.
Okay. Excellent. And forgive me because I'm kind of winging it. This is Michael's poster, but we have been working together. He's given, I think, 2 posters at European Space Weather Week, which was in November. And then we worked together. I gave a poster and a talk with him at the American Geophysical Union in December. And so this is a slightly different poster about that same topic. I want to introduce Michael as a different type of citizen scientist. He is a ninja wizard in his own right. He's basically been doing a whole lot of volunteer work on public observations of Steve that date back several centuries. He has a background as an aurora historian, amateur aurora historian from Germany. And so when he first heard about Steve, he started delving into the historical database and has found some observations there, and then continued and basically made it his quest to help build a very comprehensive database of Steve sightings, and has made this work publicly available using a new website called the, well, I don't know how new it is, but something called the Open Science Framework, where you can basically host a lot of data files. I believe you can find, if not this poster there, then his other posters and the database of observations that he's created. And so this poster is primarily about the modern observations, but there's also related work on the more historical observations. So what he has done is categorized, made a catalog of Steve events that contains over 78 observation days. Most of those public sightings of Steve the phenomena have a time associated with them. He has gotten the proper permissions for and contacted people for use of the public data. He's gotten the indices, the KP and the DST index for these times, the locations. He's looked at what type of storm, when in the storm these were occurring, and really delved into building a comprehensive catalog of Steve. What you can see in this plot here are the rate of daily observations, or of days per year, excuse me, with the Steve observations over the last several years. You can see they kind of rapidly rose: 2014, 2015, 2016, and along with the peak of the last solar cycle, they've been decreasing a bit since then, since there have been fewer storms and fewer opportunities to see Steve. But you can really see that actually, in fact, Steve is not rare. And this is important because from our traditional scientific observations, Steve is still quite difficult to catch, and particularly because it occurs in largely not the typical auroral wavelengths. It was not showing up well in many of the science grade cameras. And so, but people have in fact observed it quite frequently. There's also monthly observations here showing, again, a peak near the equinoxes. Michael has looked into this as far as the worldwide observations, the northern and southern hemisphere observations, trying to see if there's a difference. There might be some reason there's a longitudinal preference for Steve. That's still under observation. Let me see. He has really looked into categorizing the structures, and so there's many different beautiful photos here, several from Southern Hemisphere, Tasmania, Victoria, he has worked with some of these images to do triangulation on them. The image that you see here, some of the images that you see here, the Tasmania ones from Ben Swanson and Will Standring, there are different observation times, and though it's not necessarily noted on the photo here, you can also see, in addition to the green picket fence, you can start to see some structure in the lavender phenomena as well. How am I doing on time for my 5 minutes?
You have about 10 minutes left.
So I've taken 5 minutes, yes. Okay, so Michael has put all of this together. He has also looked at, in the sub-auroral zone, there are other observations, other kinds of things happening that are not Steve. He has some of those in his database and has suggestions for why these are not Steve and what they could be. He has noted observations from both hemispheres and how close together in time those observations occur, where some of the closest observations occur under an hour, and that's actually super useful as an event that we might want to study with a lot of satellite observations as well. These are also very, very rare in the last several years. So it's really a significant finding that he's put all of this together and found those. Let me see what else to say about this. It's really tremendous work. There's more that's being done here. We've recently, as I mentioned earlier today, recently in 2020 published a space weather commentary showing some of the, and you can see the link, you can find the link for it on the poster even if you can't read it on my screen. But one of the examples in that paper is this observation here of a photograph from Carl Stormer, who was a famous Norwegian auroral physicist. This photograph is from almost 100 years ago. Looks a lot like the photos of Steve that we see today. And in fact, he describes Steve, and this was overlooked. And so we wrote this commentary to bring greater light to that, as well as to the vast catalog of auroral observations that Carl Stormer completed. There may be some other rare types in there that we should really, even though this was way before the space age, that we really should be checking. So I think that I'm going to finish there so I have time for questions. Thank you. And hopefully, how was the visibility here?
I think it was good, Liz.
Okay.
It was excellent, actually.
Yeah, it was
Okay,
very
good.
readable.
Are there questions? I cannot moderate and talk, and I can barely moderate. So let me see. Jump in if you would like to ask a question.
Liz, this is Phil. I just wondered, you very briefly mentioned maybe there's enough statistics to start looking at which longitudes are better or another, or do we still need some more statistics on that?
Yeah, so the comment I would make on that is citizen science observations definitely have a geographic bias, so you can't really say, here's the absolute longitude of where Steve has been seen, right? Like, that's not a well-posed question that we can answer with the citizen science observations. However, you can say, you know, this is where they have been seen from, and based on, you know, you can try and correct for population and that kind of thing. And we do, I guess I do not really have it here, but there definitely have been more observations. I mean, they started in the Alberta area. And so it seems like there are more from that kind of region as opposed to more the European sector. But I would say that there are still only hints of that. And the underlying phenomena to the Steve is the subauroral ion drift. And those have been studied for 40 years, and there are actually very good statistics on those from DMSP observations. And those do show, I think there's a paper or two about longitudinal variations there. Although
Yes.
I don't recall, somebody here might recall better the explanation for that right now.
It would be complicated. Suffice it to say that it's not the same. It's not one of the things that other people who don't go to AGU meetings should, on this phone call, should remember is that one of the things we're kind of understanding too is that since the magnetic field axis is tilted off the rotational axis of the Earth, right? Not all longitude sectors behave the same. And in fact, here in the United States, we're in this special place where the pole is pretty far tilted off the geographic one. So the magnetic equator is 11 degrees south, for example, about of the geographic equator. You go to Asia or Europe, that's not the case. So in fact, we're finding that there's a lot of longitude or time difference in a lot of these effects, as well as the latitude stuff that we're used to. So I mean, I would be shocked if there weren't a longitude effect, frankly. But it's just interesting to see that even in these limited statistics that you're showing, there's some patterns already that are beginning to emerge that are really, really useful. Boy, hats off. That's an enormous amount of work to do that. I'm amazed.
Yes, Michael has done a lot of work. There is also a question in the chat from Carlos Martinez. Hi, Carlos.
Oh,
he asks, what about the correlation with geomagnetic activity? Are there Steves when there's no or low geomagnetic activity present? Do they occur at lower latitudes when magnetic activity is higher? And the answer to all of those is yes. So we do see, but there's not we cannot tell you exactly which storms are going to have a Steve. Most storms have Steves, but then again, there have been really only only a few small storms recently, not that many large storms. Michael definitely has those stats in his database. I'm not sure that they're in this poster, even unless I am completely missing them. No, I don't think they're in this poster, but I think they're in some of his previous posters. And so Steve definitely is seen with auroral activity. There is a correlation to substorm activity, and maybe it's seen after substorms at lower latitudes. People are starting to understand more about why that can be occurring. As far as how the substorm onsets are driven in space, and whether there's a preference in like local time, or if they're occurring further west, then you can get kind of a strange flow setup that is conducive to inducing a Steve at lower latitudes. So it's not a predictive kind of correlation yet, but as we get more events, and especially this database, that's another reason this database is really useful, is that you can then pull out the scientific observations for all of these citizen science observations and start to build better statistics than what we've got so far.
I see that Gareth has his hand up.
Awesome.
Yes. Okay. Hi. Great. It's a great poster. I commend Michael and you, Elizabeth, for putting it together. I mean, for me personally, it's great because it answers the question. When the Steve stuff really kicked up a few years ago, one of the things everybody kept asking each other is, why haven't we seen this before? Like, surely somebody has seen this before. And I was always waiting when I was at a presentation on it by yourself, Eric Donovan, for somebody in the back to stand up and be like, you need to go look at Smith et al. 64, and they talk about this. And it never really happened up until, Michael's poster and your poster, which is really, really, really great. And I just want to touch on one of the comments you said about the, how Steve kind of was missed by auroral physicists for a long time, I think. And the reason I always explain is because, we put these filters on, the auroral physicists put these filters on their cameras, and they bias themselves to, red line or green line. And it's really kind of one of those lessons, I think, as a scientist, we need to be humble and kind of eat some humble pie, in that we can't rely on our equipment so much. We have to remember that our equipment, which we use to remotely sense the ionosphere, the magnetosphere, is biasing us. And I think it's a really valuable lesson. So thank you for bringing that up again. So it's a great poster. Thank you.
Yeah, thank you for that point. It's an excellent point. And I do think in general, it's a wider point that citizen science shows us that science has its own bias, and citizen scientists can find things that we missed because for various reasons we weren't looking quite there. Yeah. So what else? And in many ways, Steve has been found and lost like possibly multiple times before. So it's very interesting. I think also just to say a little bit more about that, the Stormer observations, 7 days over the like 40 years that he made auroral observations. And then he died in 1958, and 1957 was a huge event in our field called the International Geophysical Year, as well as the beginning of satellites and all kinds of observations, and observations that led to the discovery of the substorm. And so, since for many of us in the field, most of what we think about is in the space age, and most of that has gone towards studying a lot of the high latitude phenomena. So that's
Right.
also interesting.
Thanks, Liz.